In the cabinet industry, the caliper has become practically an indispensable tool. It's used for not only for measuring accurately, it's also used for conversion from inches to millimeters. So in this video, we're going to take a look at how to read a caliper that has, on one scale, has millimeters, and on the other scale, it's inches divided into sixteenths of an inch, rather than a caliper that has inches divided into tenths or thousandths of an inch. So let's take a look at how to read the caliper. This is a typical caliper that is likely to be used in a cabinet shop. So let's take a look at some of the main parts of it. First of all, we want to identify the main scale, where all of the measurements are taken. So looking at this video, right in the middle of the video, this is the main scale. And you'll notice if we just zoom in a tad bit on the main scale, that it's the inches scale on the top is divided into sixteenths of an inch and eighths and quarter and a half and so on. Now on the lower scale, on the main scale, it's divided into millimeters. You'll see the graduations there, 10 millimeters, 20, 30, 40, and so on. That's the main scale on the caliper. Now if we look at some of the other parts or component, let's just identify components of the caliper. First of all, over here on the right, there's a probe sticking out of the end of the caliper. It might be a bar on some of the more expensive calipers, and that's for measuring the depth of a hole. Maybe you've drilled a hole for a hinge cup. Let's take a look at that, and then you can measure how deep the hole is. Or it's a hole that you've drilled for a dowel. And the upper jaw is for measuring inside measurements. Maybe you're measuring the inside of a hole that you've drilled. You want to know what is the diameter of that hole. Or you made a dado or a groove in a piece of plywood or particle board or melamine, and you want to know how wide is this groove that you've made. So you're measuring it from the inside of the hole. Then finally now, as you look at the lower jaws on this, that's for measuring the outside. So maybe you're measuring the diameter of a dowel rod, or for measuring the outside diameter. Maybe it's the thickness of a piece of plywood or melamine that you're measuring. That's what the lower jaw is for. We've spent quite a bit of time talking about the main scale. Well, now we're going to talk about the vernier scale. That's the sliding portion of it here, the sliding scale. We're going to look at how to read a vernier caliper. And for this portion of the video, I'm going to switch to a different caliper because the graduations are crisper and clearer and easier to read. Here we are all zoomed in, and you'll notice that we have the in the main scale in the middle with inches on the top and millimeters on the bottom. Another thing I want to point out is that looking at the bottom scale, you'll see that the 0 is lined up exactly with the 10. Now, a common mistake that's made here is that someone will read from the leading edge of the vernier scale, and they'd actually be thinking it was 8 instead of 10. So all of our readings, we will be watching for where is the 0 located. Let's do a little practice. Now, I know a lot of people are familiar with this, but not everybody is, so we're going to do some practice. Let's line up the 0 on the inch scale at the top with 3/4 of an inch. So now when you look at that, let's go to the bottom scale where the millimeters are, and with the 0 on the top lines up with what on the bottom? Well, if you said 19 millimeters, then you're exactly right. So 3/4 of an inch equates to 19 millimeters. Now there's going to be a little distortion here where it may not look exactly right because of the camera. Let's try another one. Let's go to 57 and see what that lines up. So let's 55, 6, 7, 57 millimeters. On the top scale, we're lining up with almost exactly with 2 1/4. So that's pretty nice. But what would happen, let's say, if we take our slider and go all the way back, and we're going to go down to 1/2 inch on the scale. There we are. 1/2 inch on the upper scale. What do we have at the bottom? It's not 12 and it's not 13. So what is it? As we look at this image, this video clip, on the main scale, a millimeter portion of the main scale, those graduations are exactly 1 millimeter. So when we go back to our scale, there's the 10 millimeters, 11 millimeters, 12 millimeters, 13, 14, 15, and so on. Our 0 on the Vernier scale is in between. Now the Vernier scale pictured here is a blow-up of one of those 1 millimeter spaces. And the blow-up of that little millimeter segment is divided into 20 graduations. Let me just show you. We have 0, then 0.05 millimeters, 0.1, 0.15, 0.2, 0.25, 0.3, and so on, until you get all the way to the end where it's 1 full millimeters. So this blow-up is taken right out of the inside of any one of those millimeter segments. So how do we determine what is the reading there, the 1/2 inch reading between 12 and 13? Well, that's done by locating on the Vernier scale a line that lines up perfectly with a line on the main scale. So as we scan across, we'll notice that the 7 is lining up perfectly with the 40. So our reading then is going to be our main scale reading of 12 plus 0.7 on the Vernier scale for a total of 12.7 millimeters. There, that's one example. Let's do one more. This time let's find 1 inch on the main scale. There. We're lined up at 1 inch. So when we look at this 1 inch and go down the scale to the millimeter scale on the main scale, and then notice the 0 on the Vernier scale is between 25 and 26. It's not exactly 25 millimeters or 26. So what is it exactly? Well, remember that each one of the segments on the millimeter scale, every one of those is 1 millimeter, and then we have the blow-up on the Vernier scale where the 1 millimeter segment is divided into 20 pieces. So we're able to figure out what exactly is the conversion from 1 inch to the millimeter scale. So because the 0 is not quite halfway, we can look at the first half of the Vernier scale, somewhere between the 1 and the 5. If we were actually over halfway through, then we'd be looking at things from 5 and up. So we know that it's less than 25.5 millimeters. So let's see if we can find a line on the bottom scale that lines up perfectly, on the Vernier scale, that lines up perfectly with the millimeter scale on the main scale. Now it looks to me like the 4 is exactly a lineup. So based on how you read the Vernier scale, that would be a 0.4. So our reading for 1 inch is 25.4 millimeters. So there it is. That's how you would do 1 inch. Well, I hope you found this video useful. And I encourage you, if you're not familiar with a caliper, to take it out and play with it. It'll make it a lot easier. Test yourself. Can you make the conversion from an inch to a millimeter and the other way around? These calipers are very useful now as we start our videos on hinges and how to calculate boring distances and reveals and overlays and things like that. So the caliper is extremely useful in that way, especially when we're working with European hinges. So if you like it, thumbs up, share it with your friends, and subscribe. And thanks for watching.